Hi everyone, this is Nitin. I'm working in data engineering team. I'm here to deploy Airflow on Azure Kubernetes. The whole objective of this demonstration is to showcase Airflow as an orchestration tool that can be used to bring all data engineering workloads in an organization under one single unified view. So for those who are wondering what Airflow is, it is an open source platform for developing, scheduling, monitoring batch-oriented data loads. So with Airflow, we can stitch the jobs that are built in, let's say, Databricks, dbt, Snowflake, or Azure Functions in one DAG or one pipeline, and we can schedule this as a workflow on Airflow. And Airflow has capability to set the dependencies between these tasks inside the DAG. So again, I'll not be diving deep into the Airflow concepts, but only provide you with the gist of Airflow architecture. And I'll even showcase how easy it is to build the DAGs and then deploy them as the pipelines. So let me jump on to the Airflow components and give you a brief of the architecture of Airflow. So for Airflow to function, we need a web server, that would be HTTP server, and a metastore database, that would be PostgreSQL. And we will need scheduler, executor, a Redis queue. So let me talk to you more about the multi-node architecture. Since we are deploying Airflow on Azure Kubernetes, so Kubernetes is known for auto-scaling functionality. So once we bake in the image of Airflow onto the Kubernetes would spin up these components as separate pods: the web server, scheduler, executor, the Redis queue. Now the web server would read the DAGs. Those are the actual jobs of Airflow. Maybe you can store these DAGs on a GitHub repository or any mount location and let the Azure Kubernetes have access to those folders. So once we have those DAGs in those folders, the web server will update these DAGs back into the metastore database. Metastore database is a PostgreSQL instance that would store the metadata of the jobs, and even the connections, the variables that are used in the jobs are stored in the metastore database. Scheduler would keep polling the metastore database to see if there's any job up for schedule. And once it knows there is a job for schedule, it's going to take the job, push it back to the executor for execution. Executor, with the help of queue, would store those jobs in a queue, and based on the workloads, it would spin up the worker nodes, and pushes the tasks back to the worker for execution. So once the execution is complete, the workers will share the job status with the executor, and with executor, with the help of scheduler, will update these details, the job status and job runtimes, back into the metastore database. So now we can see here, right, the metastore database stores so much of metadata, and with help of those tables on the metastore database, we can actually whip out a metrics dashboard for the jobs. Now the web server is a place where I think Airflow UI can start accessing the entire the DAG information, and you can see in the Airflow UI how the DAGs are scheduled and how the dependencies are set. For this demo, I will be using Azure as a cloud provider, and we will be simulating a scenario where we have built jobs in Azure Databricks. In Azure Databricks, we have multiple repositories or workspaces. So we have jobs set up there, and those jobs will simply read the data from the PostgreSQL and push the data back into the blob storage. Next, we have some stored procedures and functions developed in PostgreSQL, and we even have a function app that will just take an input of the city name and gives you the temperature of the city. So this data artifacts are only there to show you that, okay, we have the workloads are in different technologies, and now these technologies can be made as tasks in Airflow, and we can set dependencies between these tasks in Airflow. So for our infrastructure part, we will be spinning up an Azure Kubernetes service, and of course GitHub will be the place where we'll be storing our tags. Apache Airflow image will be baked into the Azure Kubernetes, and we will use PostgreSQL. The Azure PostgreSQL stands to store the metadata. That'll be our metastore, and we'll have ingress setup, mostly for providing the domain and making sure the Airflow is accessible through the domain for the users. All right, so let me jump into spinning up the infrastructure. We have a bunch of commands that we'll be using to spin up the infrastructure. So I'll be using PowerShell commands. So let me go to my Microsoft account. So this is my resource group. So in my resource group, I've already spun up the PostgreSQL instance, and we have the jobs set up in the Databricks. So now what I'm going to do is I'm going to spin up Azure Kubernetes service. So for that, I'm going to make use of a few commands. There you go. So you can see that this is the command I'll be spinning up Azure Kubernetes service with an autoscaler enabled. And next is, for this to function, we need a service principal created so that the Azure Kubernetes service has access to the resources. And in case of heavy workloads, it can only spin up to 10 pods. Since we are using a demo, we just made it 10. Otherwise, we can increase it depending on the requirement. I'm going to use a standard D8.3 version pods. I will be going ahead and executing this command. There you go. This would take about, say, 3 to 4 minutes to spin up. So I'm just going to pause the video and come back to it once this is complete. So now it is ready. So let me go ahead and check the Kubernetes service. There you go. So it is up and running. Perfect. It's all active. So I'm going to go ahead and create the namespace, create the ingress next, and then bake in the Apache Airflow image onto the Azure Kubernetes. This will be the most boring task because I just have to execute these commands, do nothing. I'm going to create the Airflow namespace, and next comes sharing the secrets. So to access the GitHub repository, we will be generating SSH key, and we will be sharing private key with the Kubernetes service, and we're going to store the public key in the GitHub repository as a path token. This is the password I'll be passing for the Redis queue. And the next is I'm going ahead and spinning up ingress. This will take about a minute or two. So I'm going to pause this video and come back to it once it's complete. When ingress is complete, so let me go ahead and execute the next step. Just going to check public IP. Just want to see if this is up. There you go. It is up. Just going to grab this. I'm trying to associate the public IP with a domain. 2 steps to go. So this would give us a domain name that we can use. There you go. This will be our domain name where we can access the Airflow UI. The next step is we'll have to wait until the ingress controller is up and running. I'm going to watch the pods. It's creating the container. So this will take another 2 minutes. So I'm going to pause this video and come back to it when it's complete. Well, we can see here right now the ingress controller is up and running. So now I'm just going to go ahead and install Airflow. So we will be using Helm charts here a lot more. That's a package manager for Kubernetes. And with the stable version YAML, that's where we have all the configurations set for how to spin up the scheduler, how to spin up a web service. I'm just going to go ahead and execute this. This would take about another 7 minutes, I believe, in the previously. So here we have a URL that we can use to access the Airflow UI. We have Flower Dashboard URL too. So we're going to access this once all the pods are up and running. We're going to watch the pods for about 7 minutes. Yeah, it's creating, so no problem so far. So I'm just going to pause this video and come back to it once all of them are up and running. And we can see the pods are still spinning up. So in the meanwhile, I'll walk you through how to develop the DAGs in Airflow. So what we will be doing here is we will be making use of Jinja templates that we have. And let me explain to you those. So we have most of the important parameters that are set in Jinja templates. And this is how the tasks are going to get spun up. We have a Python code that will generate the DAGs for us. And then let me explain the CSV for a bit. So as a developer who wants to schedule something on Airflow, all they have to do is they have to understand how to fit in the details into the CSV. So for production database, what we will be doing is we're going to push all of these data sets into another database instance. So, and the DAG generator would have access to the database instance, reads the data from that table where these will be hosted, and builds the DAGs. So that's like the automation that we'll be thinking about the production data loss. For now, we're going to store these in the CSV for the demo purpose. And it's very important to understand what's happening in the CSV. So we will slice these into projects. So GPA and Pix are the two different projects. Now a DAG would be like a big pipeline or workflow that would have tasks in it. And what kind of tasks? We're going to define them here. So when it says a Databricks exec, that's an actual Databricks job it's going to kick off. HTTP exec is another get method call it's going to make. Postgres exec is it could do any executions of a function or a store procedure. We can do that, or maybe if you want to do some inserts and updates, we can do that as well with the query in Postgres exec. So we're gonna split the data loads into 3 layers. First layer is a landing, second layer is staging, and third layer is curation. And they're all interdependent. Like say the landing finishes, only then the staging can start. Once the staging finishes, the curation can start. So where do we set that dependency? We will be setting the dependency in this particular field. So you can have a look at this. See, the first set of DAG has dependency within the DAG. So north being the parent job, there's no dependency, and the west and east job actually depends on the north job. Similarly, the south job depends on the west job. So when you spin up these as parent and child relationship, you can see the first job would be the north, then comes these 2 jobs, and once west finishes is when south is going to run. That's how the dependency will get created. So you don't have to worry about how we're doing this. All you need to know is how to fill in the details into these fields the DAG generator would take care of setting those dependencies. And I'll show you as well. Once we build these DAGs, we push them to GitHub repo. You can see in the Airflow UI how the dependencies are set in the GUI. All right. So next thing is the schedule is a cron expression to say what time the DAG has to be scheduled. And as soon as the schedule comes in, the DAG kicks off, and based on the dependencies, the tasks get kicked off one after the other. So the repo is to say, let's say if you have jobs in different repositories of the Databricks workspace, you can just put those URLs here, and automatically the jobs from different workspaces can be called in one DAG. But I think I'll make this a little more obsolete for now, because I found another way to do that using extras. So in extras field, or maybe in the let me finish the dependent jar. So let's say a job requires any jar files, you can place the location of the jar files as another dictionary like this, and the job will utilize those jars in execution of the job. Next thing is very important, like this is an extras. The extra field is something like if you want to pass some details into the DAG, you can pass those values as a dictionary here, and the job will access these key values and utilize them in job execution. So here, since it's a Databricks job, the first one, I'm just passing the job ID of that, and Databricks connection will take care of which repo it's going to execute or which workspace it's going to execute. So we ideally have to store what Databricks connection it's going to execute the job on. That's it. And trigger rule is an Airflow concept. It's like all success means it has to see in the upstream jobs, all the jobs have to be successful for this to kick off. That's what a trigger rule is. And the next thing would be a HTTP call. All you need to pass is what kind of a method and what's the endpoint you're trying to access. So these are the set of predefined variables or the dictionary key value pairs you can set. In this job, it build out an entire DAG for you, schedules them back into Airflow. The next thing is the SQL. So we are trying to execute a function here, and we're passing what SQL we are trying to execute, and we can see the output of that in the Airflow UI. Pass the connection, like how to the details of the PostgreSQL instance, and again the trigger rule is set. So this is a trigger rule is pretty much everywhere in all the jobs, because we want to know how do we execute this job. If something fails in the upstream, we don't want to run this job. So you can set this as well. So the many options you can pass, like one failed, none failed, or one succeeded. If there are 2-3 jobs, it's dependent on. If one succeeded, then yeah, that's fine. It still kicks off. So we can set these trigger rules here. It's very simple here. And here we spoke about in the first DAG, we just spoke about it. The dependencies within DAG. In the picks, what I've set is I've set the dependencies between the DAGs. You can see here, for execution of the east picks job, landing job, it is dependent on best job of Capforce landing, this one. So now all these jobs based on the cron expression, they're all triggering at the same time. But this job, some jobs actually wait for the previous job to finish. So that is something called as external task sensor I've set up. That's a concept in Airflow where you can set up an external task sensor. It waits for the job to finish. Only then it will kick off subsequent jobs. So the dependent DAGs are the ones which are very essential to set dependencies between the DAGs, within the DAGs, or the cross-DAG functionality. And similarly, what I've done here is have set up staging jobs and curation jobs. They're all Databricks jobs. And staging jobs can kick off only after the landing job finishes. So I've set up a dependency here. So once the landing job, that's a south, finishes is when staging kicks off. Same thing with the curation too. Right? So here there's a dependency on staging job. Once the staging job finishes is when they get kicked off. So now this looks very easy to fill in. So once you fill in, all you need to do is execute this tag template. It's going to read the orchestrate CSV file and sets the dependencies. So we have set up all the functions and methods that are needed to produce the tags. So we're just going to go back and see. Yep, there you go. The tags are done. So we have 3 tags in Capforce, and we have one tag in pix. If you look at the code, this is just Python script. Have all the inputs, necessary ones. So we are using Databricks operators, HTTP operator, PostgreSQL operator, Slack webhook operator is used to send out the success or the start messages of the job. If any failures also are actually logged in the Slack channel. So I've set up a Slack channel just to track the tasks, and I've set up so just easy to track the tasks for this current run. So I've just set up this. Let's go back and push these tags to the GitHub repository. So all I'm doing right now is I'm just going to copy these, paste them back to my GitHub. Okay. So before we do, let me have a look at the pods if they're up and running. Let me just check this. If they're up, oh yeah, they're up. Perfect. So what I'm going to do right now, I'm just going to go back and access the UI. There you go. So these are the DAGs, and it's still showing 17:33. I'm going to change the schedule. Right now it's 6:44 p.m. I'm just going to make sure we match the schedule so that as soon as we kick in the schedule, the jobs get kicked off. So let's wait for this. So DAGs are here. Now what I'm going to do is I'm going to show you the dependencies inside the DAG. So let's say the landing. This is how the graph looks on the GUI. The dependency is set like this. The first thing is picks off the Slack notification that it started. Then you can see the not job, and they're all dependent on the not job. Once everything finishes, Slack success comes in to send out a note that it's successful. And then if any of the jobs in the upstream fail, the Slack failure job will kick off and it will just fail the entire DAG. All right, and let's go back to the landing because there's a dependency on the landing cap force. So let me go to the GUI and show you how this looks. There you go. So you can see this job is West is actually dependent. It's an external task. Let's say if I were to show you the rendered job, see this is actually waiting on an external task here. CapForce landing API West. So it waits for the job to finish, only then it will kick off. So until then it keeps poking for the job status of West, API West, and once it finds success status, it's only when it's going to kick off the subsequent jobs. Alright, so I'll show you that in action. So for now, what I'm going to do is I'm going to go ahead and update the schedule and push these DAGs with a new schedule and execute them. So right now it's 6:45. Just going to take a head start of, let's say 4 minutes. Yeah, let me make it 15. I'm going to save this. And next thing, easy. Just go back, execute this. Latest tags get generated. I'm gonna copy this. Let's see this 646. Yeah, updated. So I'm gonna take these two tags, directly push them onto my GitHub repository. Just go here. Just replace this. Close this one. And let's go back to this. Yep. Updating schedule. So before I push to the origin, let me show you the tags right now in the first place. They're all showing 17:30 to 5:33 p.m. So now let's push this to origin. Done. Let's go back and refresh this. Takes about 30 seconds to show up the new schedule. The reason you can see the previous executions is because I've still used the same metastore database. So we have run a lot of test runs in the past, and those values are actually stored in the metastore. Now my new Kubernetes service is utilizing that. Let's wait for this. check the connections too. First thing is database connection. It is up. No change here. Just gonna go and check my connections. Postgres. Just gonna go and test this. Yeah, connection successful. I'm gonna go to the last one, the Slack. Let's go. I'm just gonna pass it here. That's it. So let's wait for the schedule. There you go. They're all up to date. So 1850, 650. Just wait for a minute, and you can see all the jobs getting kicked off, and we can have the Slack channel too. There's nothing at the moment, so let's see this. There you go. Yep, they all started. So let's see the Slack channel. Come on, guys. Yeah, there you go. They're all started. So campus landing, pix landing, staging, and curation. They all started at the same time. All good. You can see the details here. The tag just got kicked off. The timing at which the tag. What's the schedule time as well. It's going to show this. So next thing is I'm going to show you the dependency. Like say the pix landing is waiting. It should be waiting. So there is a job here, right? The wait job. So let's look at the logs. In the logs, it would keep poking for a job if it's finished or not. So there you go. It's happening. Now you can see the database jobs as well. Yeah, there you go. It's kicking off as well. There you go. So you can see some jobs since. Let's go back to API ingestion. Yeah, 650. Some jobs have kicked off. So one job that was kicked off. It's fine. Now, yeah, it's just poked again to see if the job is success. Let's see. Let's go to the landing and see. Okay, this is all complete. Amazing. The entire landing is complete. You can go back and see if it's landing. The wait job is complete too, so it's still hoping to see. Oh yeah, there you go. It's done. Success. Just found out that job completed in the upstream, so it's kicking off the rest of the job. So we can go back and show you. Yeah, there you go. One of the API ingestion tasks is also kicked off from the pix source system. Yeah, there you go. It's done. Let's see the task. Pix landing. What else is pending here? Okay. Still some more jobs that are there in pix landing. West and south. Okay, they're all done. Maybe they're all API jobs. Let's have a look at these. Go to the log. This is the API call that's happening. The Databricks job that's got kicked off. Let's see here. Yeah, this is the one, of course. Now let me go back and see if Pix landing is complete. So all of them are complete. Oh, there is a failure. Okay, that's a task fail. It's skipped. The pink color means it's actually skipped. The final status is green, so everything is green. The next step is to check staging. Staging also might be low waiting, but then yeah, it's almost completed. The wait job finished. Of course, still landing finished. That's great. So all are done. So we can see jobs and curation got kicked off as well. Yeah, I'm just talking about staging side. Yep, 53. The jobs got finished. So it is able to kick off the jobs and wait for the jobs to finish as well. So this is how I'm trying to demonstrate that we can set the dependencies between the DAGs, in assuming the tasks in the DAGs are scheduled in different repositories or different technologies. We can bring all of them under one DAG. So when duration is finishing, yeah. Looks like all the jobs are done. Yeah, perfect. They're all done. This is how you can see the job status and you can tracking the jobs. Next thing is you have the logs. Let's say if you want to kick off one of the logs, you can click on this, go to the logs. There you go. So entire log details will be right here. And this is another Databricks job that's kicking off in the curation layer. So just actually pause the Databricks repository to see if the job completed, and then it just keeps track of the tasks. Now, yeah, there you go. So this is the dependencies that are set inside the job. Let's go back to the Slack channel. Yeah, they're all success. Started, they're all success. All are done. So this way you can see status in your Slack channel. And let me show you the Flower UI. What does Flower UI contain? So in Flower, their dashboard, you can see the tasks and the workers that have spun up. We have 2 workers and how many tasks got succeeded on that worker. So it actually splits the tasks based on the workload into these workers. It says process 35. So you can see the executors that are actually working. So the Flower dashboard actually gives you an idea about that. All right. The next thing I would like to show you is the connections. Airflow can connect to any modern data engineering stack. Databricks, Snowflake, it has all the connectors right here. And you can whip out a connection and start executing the jobs as DAGs. So it's got all of them. Azure, Google, AWS, you name it, you got it. And any modern data engineering stack. So if in case you don't have the connector, all you need to do is pip install those as part of the web server spinning up. And in the YAML, you can just put that out here. And you can upgrade to a new version in the Helm charts. So let me show you that as well. I have a stable version here, so I'm going to open this. So all you need to do is go back to this, and you can put in the connectors and softwares that you need. There you go. So you can actually import those providers here, and automatically they'll show up in connections. And all you need to do is a simple command on the PostgreSQL again to just update. So you just have to put upgrade, give the version of the YAML, and it will automatically not even bring down the existing process, just a little upgrade without any downtime. Well, that is about the demonstration of how easy it is to build the DAGs, put them back in schedule, and track these tasks in the DAG in the Airflow UI. If you have any questions, please reach out to me. I'll be happy to answer. And this will be the end of the demo. Thanks, guys.